Welcome everyone. I am Mr. K Kulkarni, working as an assistant professor in Department of Mechanical Engineering at Walchand Institute of Technology, Solapur. In today's session, we will be discussing about crossed belt drive. At the end of this session, the students will be able to learn the basics of crossed belt drive. They will be able to derive the length of belt for crossed belt drive. Also, they will be able to calculate the length of the belt for crossed belt drive. So first we will understand what is meant by crossed belt drive. A crossed belt drive is a type of drive in which the driving and driven pulleys are connected by a belt that crosses each other. So here you can see this is the driving pulley and this is the driven pulley, and they are rotating in the opposite direction. They are meant to rotate in the opposite direction. That is why we use the crossed belt drive. In crossed belt drive, the belt cross each other. They are particularly used in machines where space constraints or design limitations are there. These limitations, they necessitate the use of crossed belt drive. Advantages of crossed belt drive include space saving, efficient power transmission and higher torque transmission. There are limitations that include increased wear and tear, limited shaft distance, we cannot increase the shaft distance, as well as the maintenance is complex because there is not one defect, there may be multiple defects. Applications include automotive engines, textile industries, conveyor systems, small machine tools and printer and paper machines. All these are the applications of cross belt drive where space constraint is there. Now let us see the derivation of length of crossed belt in the cross belt drive. So if we consider R as the length of smaller pulley, in this case AC is the length of smaller pulley. Capital R, that is BF, is the length of larger pulley, and AB is equal to center distance between the pulleys. And again beta is the angle subtended by each common tangent. Now, as in the length of open belt, we have seen length of arc is equal to twice arc GC plus CD plus DH. This is the length of arc and we have to multiply by 2 because it is symmetrical. Now we'll find out the individual components. First component is length of arc GC. So length of the arc GC can be calculated by angle into radius. So angle is again pi by 2, that is GAC. Angle GAC is pi by 2, 90 degree plus beta into radius of smaller pulley, that is small r. Next we will find out CD, that is equal to AN. So in AN can be categorized as AN is equal to C into cos beta as in the open belt drive. Next, length of arc DH can be calculated as pi by 2, again this pi by 2 plus beta. This is DH, this is pi by 2 angle DBH, that is pi by 2 plus angle beta. So pi by 2 plus beta into capital R, that is radius of larger pulley. So adding these three terms we get L is equal to twice pi by 2 plus beta into a small r plus C cos beta plus pi by 2 plus beta into capital R. So expanding these terms we get the length, that is pi into capital R plus small r plus 2 beta into capital R plus small r plus 2C cos beta. So this is the exact length of cross belt drive. Now we'll approximate some approximations for small angle beta. We can calculate or we can approximate beta is equal to capital R plus small r upon C, and cos beta is equal to 1 minus half capital R plus small r square upon c square. This is the two approximations that we get. Next, we already have this formula. L is equal to pi into capital R plus 2 beta into r plus r plus 2c cos beta. That is the exact length of the cross belt drive. Next, substituting these values, these two approximations, L is equal to pi into capital R plus small r plus 2 into substituting the value of beta as r plus r upon c into capital R plus small r plus 2c substituting the value of cos beta as 1 minus half capital R plus r bracket square divided by c square. So we get L is equal to pi into capital R plus small r plus 2c plus capital R plus r bracket square upon c. So this is the approximate length of the cross belt drive. Now we'll solve one problem. The problem is that two parallel shafts 6 meters apart are to be connected by a belt running over a pulley of diameter 600 mm and 400 mm respectively. So we have two pulleys of diameter 600 mm and 400 mm respectively, separated by 6 meters apart. We will find out the approximate and exact length of the belt in a crossed belt drive arrangement. So given values are capital C is equal to 6 meters, capital D, that is the diameter of larger pulley, is 600 mm, small d, that is diameter of smaller pulley, is 400 mm. Radius of larger pulley can be calculated as capital D upon 2, that comes out to be 0.3 meter, and radius of smaller pulley, that comes out to be 0.2 meter. Now we'll find out the exact length by using this formula that we have already derived. L is equal to pi into capital R plus small r plus 2 beta capital R plus small r plus 2c cos beta, where beta is equal to sine inverse of capital R plus small r upon c. Now we will first find out the value of beta. Before that, first you have to take into consideration that your calculator should be in radian mode before solving this problem. So substituting the value of capital R, small r and capital C as 0.3, 0.2 and 6, we get beta is equal to 0.08342 radians. L is equal to pi into 0.3 plus 0.2 plus 2 into substituting the value of beta as 0.08342 into 0.3 plus 0.2 plus 2 into 6 into cos of 0.08342, which comes out to be 13.61249. The more decimals you take, the more accuracy you get. So exact length of cross belt in a cross belt drive arrangement is 13.61249 meters. Now we'll find out the approximate length by using this formula that we have already derived. L is equal to pi into capital R plus small r plus 2c plus capital R plus small r bracket square upon c. This is the formula for approximate length. So substituting the value of capital R, small r and capital C, we get pi into 0.3 plus 0.2 plus 2 into 6 plus 0.3 plus 0.2 bracket square upon 6. So we get L is equal to 1.5707 plus 2 into 6 is 12 plus 0.04166. So we get approximate length as 13.61236 meters. This is the approximate length that we have got, which is close to the exact length that we have got in the previous slide. So 13.61249, that is the exact length we have got, and 13.61236 meter, that is the approximate length we have got. So we have to calculate the exact length and the approximate length, and you can see the difference as 13.61236 and 13.61249 meters. These are the references that we have referred. So thank you.